Hello everyone, my name is Spencer Averbeck. I'm a fourth year PhD student at the University of Pennsylvania. In this video, and then in the next couple of videos, we're going to be discussing some issues that you might encounter if you ever work with electrochemistry for characterizing these bioelectronics. We're going to cover some issues you might run into. We'll discuss what could be causing this issue and then how to fix or troubleshoot these issues. But briefly, this is our setup, generally speaking. We have our potentiostat for our electrochemical measurements here. This black box here is the multiplexer. So our potentiostat that we're using is the Gamry reference 600, and our multiplexer, this black box here, is the ECM8 electrochemical multiplexer, and that allows us to look at the function of up to 8 channels in order. And beyond that, we have our electrochemical setup right here. Let's see if I can't zoom in on it a bit. So right here is our electrochemical setup. And you can see here we have our carbon rod. This long black rod is our carbon rod counter electrode. We have a small silver chloride reference electrode right here, and hanging from all these wires into the solution is our 6 working electrodes. And our working electrodes in this setup are 6 gold pins on a flex PCB cable. And so we will be using this multiplexer here and the potentiostat here. We're going to go through some standard electrochemical measurements and discuss, what they should look like, what they shouldn't look like, and why you might see some errors in those measurements. Alright, so let's say you have your entire experiment set up and you wanted to run some characteristic measurements that are really commonly collected when looking at bioelectronics. Say we'll look at electrochemical impedance spectroscopy and we'll look at cyclic voltammetry. So I have a script in our experiment sequence wizard that will run both of these through the multiplexer on all 6 of our gold channels. So we have cyclic voltammetry here, and we have the potentiostatic EIS here. So we're going to go ahead and hit run sequence on that, and all of a sudden you will see our experiment pop up. So it's asking that I want to make sure that I'm using the this potentiostat, and yes, I do. I have run this before, so I'm just going to replace all of these files with these new ones that I'm collecting, and I'll maximize our screen. So we're starting out with cyclic voltammetry on channel 1. As we can see, it looks fine, it looks normal. We can see clear oxidation and reduction peaks occurring. This is not the best gold, so there's probably some non-gold related mechanisms occurring as well. Now we're running our electrochemical impedance spectroscopy, and so far so good, and things went wrong. So now you can see there's this flashing red light here on the bottom of our screen, and we can see that there's a huge discontinuity where we were looking at really low impedance measurements here, and all of a sudden now it's just terrible measurements. And so this is the first sign that, hey, maybe something is wrong. It's not apparent exactly what could be wrong because this cyclic voltammetry, now running on channel 2 here, is working just fine, right? So you could come in and you'd say, okay, well, my cyclic voltammetry is working fine, but for some reason my impedance spectroscopy is not working fine, or it works fine at the beginning and then it stops working fine. What's wrong, right? And so clearly we have everything hooked up correctly, so all of our we have our reference electrode and our working electrode and our counter electrode all in place. They're all clearly connected to the Gamry. So something's wrong. And so this time it didn't even do the discontinuity, right? This time it just stopped halfway through the measurement and just says there's a bad value. And so we'll just terminate this experiment. So now we'll start looking at channel 3. And again, we see that our cyclic voltammetry is working just fine. But it seems that we're having problems looking at the impedance spectroscopy for these electrodes, and it doesn't seem apparent that the way that it breaks down is the same either. So we start to get flashing, and then here, just like on channel 2, but not like channel 1, we get the terminate EIS scan saying a bad value warning. So we'll terminate this. We'll look at channel 4 here. Again, CV is working fine, and we just don't know exactly what's wrong with our impedance spectroscopy. And so this could be coming from a number of things, but the most readily apparent and generally the rule of thumb in electrochemistry is if something is going wrong, check your reference electrode. So there's a good chance that something is happening with the reference electrode here, that it's just not able to have a low enough impedance of its own to measure this impedance of our working electrodes. With that being said, although the rule of thumb is to check the reference electrode, the first rule of thumb is to make sure everything's connected correctly, which we've already done, which is why we're able to see that measurements are coming in, and they're coming in correctly. We can run our cyclic voltammetry, and it works fine. The very first step is always to make sure that your reference, counter, and working electrode aren't touching. They're all plugged in. There's no connectors that are submerged in the water as well. All the connectors are touching. The connectors aren't touching some other metal that's not a part of your system. Everything's plugged in. Those are really the first steps, but once you have established that and you can see that your data is being collected, the next step is normally to look at the reference electrode. And so that is what we will do now. And to do that, we can use our setup here. We have a small setup out here, and we can do this by taking our reference electrode, which is this guy here. So we'll take our reference electrode and we will hook it up according to the Gamry's instructions. The Gamry has a test reference electrode measurement installed, so that is one of the tests that you can run, is test your reference electrode. So we'll hook our reference electrode up there. Then we will take our carbon rod counter electrode and hook that up on the other side here. And then the last step is I will switch over from the multiplexer to the single channel data collection style. So now I have that all hooked up. We have our reference, which is currently being connected to our blue working and our green working sense, and we have our carbon rod counter being hooked up to our typical reference and counter electrode. So now that we've got that hooked up, we can go back to our measurement window here. We'll zoom in on that as much as we can, and we can go to experiments and measure reference electrode impedance. So it'll pop up some default settings. We'll hit OK. And it gives us this little warning to say connect the green and blue with the reference electrode and connect the red and white with the carbon with the counter. So we'll hit OK. And it very quickly will run this measurement. And it'll give us some warning. So it says reference electrode impedance too high. A frit change is recommended. So we'll hit OK because our reference electrode impedance was about an order of magnitude too high of impedance for what we'd want to see for when we run our measurements. And so we will say that we have So that could definitely be our source of error here. And now if I were to use or refresh this reference electrode, or say use a different reference electrode that I know works now, so I will take apart our little mini cell here. I just pulled out our reference electrode, so now I'll pull out our carbon rod electrode, and I'm going to rehook this back up to our original setup with our gold electrodes. So we'll move our working electrode back. We'll put in a new reference electrode that we know works, and we will rerun these measurements now. So now we'll close out of this reference electrode measurement here. So I keep this stable. There we go. So we'll close out of our reference electrode test measurement. We'll go back to our sequence wizard, and once I change this cable over, that's out of screen, back to the multiplexer cable, like so, we can go ahead and run this sequence. And so again, it's just asking that we've got the right potentiostat, which of course we do. And we're going to replace this data again because we just collected this data that was all faulty. And so just like before, we're going to see our cyclic voltammetry working just fine, just like we expect, because that will work even with a relatively high impedance reference electrode. And so the real test will come when we look at our electrochemical impedance spectroscopy, which should be coming up just right now. And as we can see, it's flying through our frequencies with no problems at all. There's no discontinuity, there's no stopping of the signal. So it looks like our reference electrode really was the problem, and either by refreshing the frit, which I'll have a different video explaining how to do, or by changing the reference electrode with one that already works, we can re-establish a functioning electrochemical measurements. And this should really help clear things up for future measurements. So it's not always inherently apparent what is going wrong with the Gamry or with your electrochemistry when you show up one day and things are going awry. But it's always important to kind of follow these general troubleshooting steps if problems do occur. So of course making sure that all of the connections are made, your working electrode is functioning and is actually able to show electrochemical values. Nothing is shorted, nothing is disconnected, and once you've done that, if you're still having issues, or if you're having any issues, you would want to check in on the reference electrode, because again, the rule of thumb is that it can normally be always traced back to the reference electrode. And so we can see here we've just gone through channels 1 and 2, and now channel 3 is flying by with amazing results and very clean data. So the reference electrode was our issue of today. So hope this helps.